Now, we're going to start talking about different kinds of molecules called aldehydes and ketones. Now, vanilla, the flavoring vanilla comes from a particular molecule called vanillin. It's extracted from vanilla beans, right? Look at this molecule. It has 4 different functional groups on it that we would classify. This ring right here is what kind of ring? It's a benzene ring, so what kind of molecule is it? It's an aromatic. It has this down here, which makes it what? What's the OH make this? It's an alcohol, right? And then it has this right here. It is a what? Somebody said it. It's an ether. Okay? So it's a aromatic ether alcohol. And then it also has this thing up here. It's also an aldehyde. And we're going to talk about what defines an aldehyde and a ketone. Okay? So, aldehydes and ketones contain what's called remember, OH minus, or not OH, minus, was called the hydroxyl group, right? This is called the carbonyl group. C double bond O, carbonyl group. When you have a carbonyl group, you are an aldehyde or ketone. Okay, C double bond O. Aldehydes are carbonyl groups that also have a hydrogen on the carbon. Okay? Ketones are carbonyl groups that do not have a hydrogen on the carbonyl carbon. So think about, here's our C double bond O, and there's a hydrogen here, right? It's a hydrogen. So that makes this an aldehyde. There's no hydrogen on this carbon right here, so this must be a ketone. Okay? Another way to think about it is, when this carbonyl carbon is on the end of the molecule, it's going to be an aldehyde. When it's somewhere else in the molecule, it's a ketone. Okay? So if it's on the very end, there's going to also be a hydrogen on that carbon. It'll be an aldehyde. Okay? Does everybody understand that?
Can you do that again?
This one, look, there's a hydrogen on this carbon, right? That means it's an aldehyde. It's also on the end of the molecule, so that means it's an aldehyde. This C double bond O is in the middle, therefore there's no hydrogens on the carbon. Why can I not have a hydrogen on that carbon right there? Why are there not any hydrogens on it?
Because you have 5 total.
Because then I would have 5 total bonds. Carbon can't have 5 bonds, can it? It's only have 4. Okay? So, oftentimes when you see the condensed structural formula for an aldehyde, you'll see it written like that. CHO. And we just understand that this really means C double bond O with an H like that, and then there's some other stuff over here. Okay? If it's a ketone, it can just be written as CO because it's in the middle of something somewhere. And the O is bonded to the C that it just came after, right? So here we have the structural formula, the condensed structural formula. Note that this oxygen right here is bonded to that carbon right there. Okay? This does not mean that the oxygen is bonded to both carbons here like an ether. It doesn't mean that it's an ether. This means it's a ketone. Okay? We're not going to worry about naming them. How's that? There's a vanilla bean. So, vanillin, and when you buy vanilla at the store, It has about 35% alcohol in it. They use the alcohol to extract the vanillin from the bean and the seeds. That's why, since it's 35% alcohol, that's roughly like what liquor is, right? Like rum is like 40% alcohol, gin and vodka, most of those are around 40% alcohol, 40 to 45%. So that's why alcoholics will often drink if they can't. If you lock them up in a house and not let them out, they'll go through the pantry and find vanilla and drink it.
I didn't even know it had alcohol.
Yeah, it's got a lot of alcohol in it.
This is not bottle.
It's a small bottle. It'd be like taking a shot, right? And it tastes awful.
It smells good.
It smells very good, but that's why you only use like if you bake with it, you use what, like a
A few
quarter or a
teaspoons,
teaspoon, right? You hardly use any at all. But when you're an alcoholic and you're jonesing for some alcohol,
It's gonna make it throw up.
So does it go bad quickly? Does it evaporate after you?
now it will if you leave it open. That's why you have to leave it closed very tightly, right?
Can you tell me why they're always in the dark?
Because the sunlight will decompose the vanillin.
I can't believe you
I got lots of useless knowledge in my head.
do. Lots of trivia questions.
One of my ex-wives used to call it the treasure trove of trivial trash,
Treasure trove of trivial trash.
because I know so much crap that most people don't know. But it's useful for me, right? I mean, I have used reagents and stuff that are stored in the dark because sunlight will decompose them. And vanilla is one of, it'll change the flavor. If you take that bottle and sit it outside, or you dump it into a clear bottle and sit it outside for a week, it'll taste different than it would if it was in a dark bottle in the house. Yeah, there's lots of reactions like that. The sunlight's enough energy to catalyze a reaction.
So we'll have the same volume?
If it was sealed up, it'd still have the same volume, but the vanillin would decompose into other
But
compounds.
as long as it's not exposed to sunlight, which most people take it home and put it in their cabinet.
That's right, then it's okay.
It's okay.
Yep.
Never like it vanilla.
Oh, we're not gonna name ketones. Ketones end in the name O-N-E. Anytime, so when you go home and look at your shampoo bottle and you see something that ends in O-N-E, that means it's got a ketone in it.
So it's got an oxygen double bonded to a carbon somewhere.
Somewhere in the middle of it, yep. Anybody ever had their ketones checked? I know you have your mama, right?
Oh,
You got children,
I do, yes.
and you never had your ketones
I'm
checked.
sure, yeah. I mean, most anybody that goes in and has any kind of basic workup done, they go to it.
I'm talking about when what? When you are with child. Pregnant, right? Every time you go to the doctor when you're pregnant, they check your ketones. They do it with a little dipstick, right? They pee in a cup, they dip a little stick in there in your urine, and they check to see if you're leaking ketones. Why do they check to see if you're leaking ketones?
I have no idea.
No idea? It can be a sign of gestational diabetes.
That's when they give you that stuff to drink. And then you-
Well, that's when they really do a serious check in. Yeah, that's big time then. This is just like, oh, you're pregnant, here, pee in the cup, let me check, see if you're leaking ketones. Or if you're on a very low carb diet, like the Atkins diet, you will start to, most people don't excrete ketones. But your body has a metabolic pathway by which it will make and excrete ketones if you stop using carbohydrates, right? You will start leaking ketones, is what it's called. Okay? It's called ketosis.
But if they check, most anybody, if they check your urine, you go in the ER and they want your urine.
They'll check, yeah, because they want to know if you might be diabetic or not. Yep. Because diabetics often leak ketones because they're not metabolizing the sugars correctly, right? And so they're giving off ketones. Does that make sense? So,
What is a ketone?
what is a ketone? It's a molecule with C double bond O, not at the end. There's no hydrogens on that carbon, right? Look at these guys down here. They all have C double bond O and there's no hydrogens on the carbon. It's a byproduct. The small ones are byproducts of certain metabolism processes in your body. But your body would normally do even more to it. It wouldn't give them off. Okay? It comes from sugar, from when your body metabolizes sugar.
So maybe the sugar metabolism is incomplete?
That's right, and that's why you're diabetic.
Okay.
Yep. We're not gonna name them. How's that? Everybody happy with that?
Mm-hmm.
So, what are the properties of aldehydes and ketones? Well, ones that are small, just like alcohols, are soluble in water. If you have 4 or fewer carbons, you're soluble. If you have more than that, you're not going to be soluble because you're not polar enough. So just like with alcohols, the general cutoff is 4, right? With alcohols, 4 was sparingly soluble. With aldehydes and ketones, 4 means, yeah, you're sort of soluble, okay? So here's a couple of common ketones. Acetone, and you ladies that use nail polish remover are familiar with acetone, right? You can actually buy nail polish remover that does not have acetone in it. I learned that a few weeks ago.
Doesn't
Not
work as
get
well.
your fingernail.
It doesn't work as well.
Yeah, but it's also better for your fingernails. Because the acetone will dry your fingernails out so bad and cause them to become brittle if you use it a lot.
So what is
I learned that a couple weeks ago too, I didn't know that.
But they
By the
give
time
you
you s-
oil though, like at a nail salon, they put oil on
That's to try to replace they're trying to put because when they use the acetone stuff, they know it's drying your nails out, they're trying to rehydrate your nail so it doesn't become brittle.
Because you use that other stuff, they don't have to basically take your nail off to get the polish off. It's so hard.
I don't use any of it, so I don't really know. That's, not my thing. Formaldehyde is a common aldehyde. Formaldehyde used to be used as a preservative for specimens, stuff like they have an octopus in a jar there, right? We don't use formaldehyde anymore to preserve specimens. I think they're using formalin and some other stuff now. I don't even remember what they're using all the time now. But we don't use formaldehyde much anymore as a preservative because formaldehyde's not very good for you either.
Wasn't it put in like houses and mobile homes and stuff?
Well, it's a byproduct of some of the insulation and stuff that they use. Some of the products outgas formaldehyde as they break down a little bit. They outgas formaldehyde. So like if you go into a brand new RV that's shut up, your eyes will burn, and that's because of the formaldehyde coming out of the insulation and stuff. Yeah.
When did they stop using that as a preservative?
Within the last 10 years. It's not used very, like if you go in the biology lab and you dissect something, it used to come in formaldehyde, now it's not in formaldehyde anymore. So like, if you take biology and you dissect a frog, it's not preserved in formaldehyde anymore. When I was in high school and we dissected frogs, they came in a big bucket full of formaldehyde. They use formalin and some other stuff now. All right, so tell me, look at these and decide is it an aldehyde or a ketone? Yes, ma'am.
The VMT,
Mhm.
when we were dissecting cats, I thought she said that we used formaldehyde.
Some things they may still use it, but it's not, they don't normally use formaldehyde anymore. I mean, I know all the stuff we have in our biology labs are all formalin now, not formaldehyde. Because the formaldehyde is so toxic. Yeah. But some things they may, I guess, maybe still use it, but not many.
I think they still use it on fetal pigs, because we did that in high school. She said it was formaldehyde.
She may not have known that it's not formaldehyde anymore. I don't think because we have some fetal pigs and it's not, it's in formalin. So which ones of these are aldehydes and which ones are ketones? A is everybody agree A is a ketone? Look at the carbonyl carbon. There's no hydrogens on it, is there? So it is a ketone. What about B? It's an aldehyde. There's a hydrogen on it, right? What about C? Aldehyde. And D? little bit of confusion.
Can you,
Are there any hydrogens on that carbon?
could you explain what you mean by there's no hydrogen?
You know, H's.
Is there a hydrogen bonded to this carbon?
No.
Yes, there is. There's one right
Yes,
here.
there is, there is.
So it's an aldehyde. Okay? This one, there's no hydrogens on that carbon. So it's a ketone. What about this carbon right here?
Well, the A could be confusing because you got 2 hydrogens to the left of the carbon.
No. Here?
Yeah,
No. These two hydrogens are on this.
okay.
If you draw it out, it looks like this. These two hydrogens are not on that carbon. Remember how we write our condensed structural formula, right? These two hydrogens go with the carbon that you just passed. That's what it looks like.
Okay.
Are there any hydrogens on this carbon?
No.
It's got 2 bonds up here and 1 down here and 1 down there. There's no room for any hydrogens, are there? So it is a
Yeah, line would be wrong.
ketone, right? Ooh, we don't even care about that.